solving quadratic equations. So I have a few quadratic equations I want to mess around with here. This is related to using square roots, completing the square, and the quadratic formula. First, we have to solve for z in the equation 5z squared equals 245. And so we want to isolate the variable and use square roots here since there's only one z, the z squared. So I'm going to divide by 5. And so on this side I get 5 divided by 5, which is 1 times z squared, and 1 times z squared is z squared. On the other side I have to take 5 into 245. So let's go off over here, and 5 goes into 245. Let's see, 5 goes into 2, no. 0 times, 5 goes into 24. 4 times 5 is 20. Remainder 4, bring down the 5. 5 goes into 45 9 times, so that's a nice number. 9 times 5 is 45. And we definitely get 0 remainder, so we get 49 on the other side. And I like the 49 because now when I take the square root of each side, the square root and the square undo each other on the condition that we put a plus or minus on the other side. Then I have the square root of 49 sitting there. Well, the square root of 49 happens to be 7, so I get either plus or minus 7 for z. So we have two answers. Either z is 7 or z is negative 7. And so now, next we want to check. So let's do that over here. So always go back to the original. So in the original equation I have 5. When you check, replace the variable with a parentheses. And it's questionable whether this is equal. I don't know yet. And I'm plugging in there that 7 or the negative 7. So first we'll do the 7. 7 squared is 49. And so now I have to check what 5 times 49 is. Well, if my division was right, that should be 245, but let's check. So 49 times 5. 5 times 9 is 45. 5 times 4 is 20, plus 4 is 24, and yeah, that equals 245. And so I get 245 equals 245. Right? Same 245 coming down, arithmetic on that side, check. If we try that for the negative, we're going to get 5 times negative 7 squared, parentheses are important, question mark, equals 245. And then the cool thing here is a negative times a negative is a positive, so this is 5 times 49. And 5 times 49, as we saw over there, is 245. So I get 245 equals 245 on the other side, and it does indeed check. And when you're checking, you're just doing arithmetic on each side. So I have arithmetic on the left, nothing on the right, and I get the same answer on each side. So I have confirmed that these are the solutions. Next. So this one right here, I decided to use the quadratic formula. So I have a slight error in my formula. That should be a square. So some number times x squared plus some other number times x plus a third number, and a, b, and c could be the same, who knows, equals 0. Sorry about that. The quadratic formula says if you have an equation that starts looking like that, then the solution looks like this, right there. And it's just a matter of identifying a, b, and c. So let's see. A, I believe, equals 8, and that's an A, not a 9. And B equals negative 22, make sure you get the sign right, and C equals 5. So then I just, in this formula right here, replace. So x is the opposite of negative 22, plus or minus the square root, and make that big to make sure I have room, b squared, so negative 22 squared minus 4 times a is 8 and b is 5 all over 2a. So that would be 2 times 8. All right, so a little arithmetic off to the side. Negative 22 squared. Well, negative times a negative is a positive. So basically I got to figure out what is 22 times 22. 2 times 2 is 4. 2 times 2 is 4. Move over. 2 times 2 is 4. Lots of 4s here. And we get 4, 8, 4. So I have 484. And then from that I have to subtract 4 times 8 times 5. Okay, so let's see. Let's go over here, say. 4 times 8 times 5. 4 times 8 is 32. 32 times 5. 5 times 2 is 10. 5 times 3 is 15, plus 1 is 16. So now I have to subtract that. So over here, I want to subtract 160. So 4 minus 0 is 4. 8 minus 6 is 2. 4 minus 1 is 3. So I have 324 in there. And I have to take the square root of that. So what is the square root of 324? To figure that out, I need to make a factor tree. So it's even. So 2 goes into 324. Let's see, 2 goes into 3 once, with 1 left over. 2 goes into 12 6 times. 2 goes into 4 twice. And then that's still even. 2 goes into 16 8 times, and 2 goes into 2 once, so 81. 81 is 9 times 9, and that's nice because anytime you have a pair of factors inside a root, they pop out as 1. So that tells me right there that the square root of 324 is 2 times 9, or 18. That's nice. Alright, so opposite of negative 22 is 22. And then I get plus or minus 18, all over 2 times 8, which is 16. That means I have two solutions. One of them is 22 plus 18 over 16, comma. The other is 22 minus 18 over 16. So now we have to clean those up. Let's see. 22 plus 18 would be 20, 30, 40 over 16. And that probably reduces, let's see, what, 8 goes into both of them, I believe. And if you weren't sure about 8, you could divide 2 in, and then 2 again, and 2 again, see what happens. So let's see, 8 goes into 40, how many times? 5 times? And 8 goes into 16 2 times, so it looks like 5 halves is one possible answer. And the other one is 22 minus 18, which is 4 over 16. Let's write that a little bit higher here. And 4 divides both of those. And it really is important that you not just think this, you write it down. Confirm to yourself it's correct. 4 divided by 4 is 1, 16 divided by 4 is 4, so it looks like another possible answer is 1/4. So next we have to check them. Let's see, do we have enough room on this page? Perhaps. Yeah, we do. Okay. So let's check. So to check something like this, we have to plug the original number back in. And I'm going to stick with fractions here, although decimals would work because dividing by 2 is nice and dividing by 4 is nice. And to check, we have to go back to the original, which is 8x squared minus 22x plus 5. So let's move back down. And we're just going to rewrite that, but with parentheses. So 8, instead of an x, we have parentheses squared, minus 22 parentheses plus 5. And that's supposed to be equal to 0. Make sure we copied it right. Looks good. So we'll plug in the 5 halves first, and then we'll try the 1/4 and see what happens. Alright. here, 5 halves goes there. Order of operations, we should square first, so 5 halves squared is 25 fourths, and that's being multiplied by 8, minus, there's nothing to do inside the parentheses, so I just have to take negative 22 times 5 halves, and we could view that as negative 22 over 1, and 2 goes into 22 11 times, so that's 11 times 5, which is 55, what we're subtracting. And then we have a plus 5 hanging out, 0 on the other side we'll wait for. Cleaning up this side here, we can view that as 8 over 1, 4 goes into 8 twice, 2 times 25 is 50, so we have 50 minus 55 plus 5. 50 minus 55 is negative 5, plus 5 is 0, which matches the 0 on the other side, right? And so that checks out. So next we'll try this for 1/4. So 8 times 1/4 squared, and be safe with parentheses, minus 22 times 1/4 plus 5, is that really 0? And unless I made an error in my arithmetic, it should work, but we really have to check. So 1/4 squared is 4 times 4 is 16, so that'd be 1/16 times 8, minus, and like before, we can view that as 22 over 1, and it doesn't clean up as much, but I can say 2 goes into 4 twice, 2 goes into 24 11 times, so I get 11 halves there, plus 5. Let's see, 8 and 16, well 8 goes into 8 once and 16 twice, so I get 1/2 minus 11 halves plus 5. 1/2 minus 11 halves is 10 halves, but negative. And 10 halves is really 5, so that's negative 5 plus 5, which is 0, and then we have a 0 on the other side, which matches, so that's a check too. So this is no longer a question mark, it is checked. So now I believe that these are the two answers, and let's highlight them. And so those are my answers. Let's see, what's my variable here? I think it was Z or X. It was an X. Yep, so I get, oops, try that again. I get X equals those two numbers. Cool, they both check. Next. Alright, x squared plus 6x equals 2. If we're going to use the quadratic formula, we would have to get 0 on the right, or we can complete the square. My usual philosophy is if there's a 1x squared, which I have here, and an even middle term, right, that 6 is even, then what I'm going to do is I'm going to complete the square. I find it's a few steps faster than quadratic formula. But we could use the quadratic formula. If you were going to use the quadratic formula, then we would rewrite this as x squared plus 6x, subtract the 2 over, equals 0. And then you could use the quadratic formula like we did on the previous problem. I'm going to go for completing the square. So I'm going to rewrite this as x squared plus 6x space equals 2. And then the middle term, which is the 6x, that 6 is important, that's what we call b. So b equals 6 here. And then I want to cut that in half, so it's b over 2, and that would be 3. And then I want to take that b over 2, and I want to square it. And so that would be 9. And 9 is the first magic number. So next I'm going to rewrite this as x squared plus 6x, and then I'm going to add that 9. Now to keep things in balance, i.e. equal, then I have to also add 9 to the other side. So I'm doing a plus 9 on each side to keep things equal. The point of doing that is this is now a perfect square. That is the square of x plus 3. And so here's that other magic number there. And that's equal to 9 plus 2, 2 plus 9, which is 11. Once I have that, I can take the square root of each side. So I'm going to have the square root on each side. And so that's the square root of x plus 3 squared. And that's equal to the square root of 11. On the left, the square root cancels if I put a plus or minus on the other side, and I'm stuck with the square root of 11. 11 doesn't factor, so that's it, square root of 11. Without a calculator, that's all I got. Shift down a little bit. Last step is to subtract that 3 to the other side, so I'm going to get x equals negative 3, because I'm subtracting it over, plus or minus the square root of 11. So I have two answers. One is negative 3 plus the square root of 11. The other is negative 3 minus the square root of 11. So now I need to check. So to check, I got to do a bit of work based on the last chapter we worked on. So let's scroll back up, and we'll check over here. So I'm not going to use the quadratic formula, but I'm going to check the answers I found. To check, I have to plug them into the original equation, which was x squared plus 6x equals 2. And to do that, I use parentheses. So instead of an x, I have parentheses squared, plus 6. Instead of an x, I have parentheses, and I'm hoping that that's equal to 2. And let's start off with the harder version, which I think would be like the negative one, which would be negative 3 minus the square root of 11. Negative 3 minus the square root of 11. So again, I am plugging in this answer right here that I found. Okay, so to square something means to multiply it by itself, so then I have negative 3 minus the square root of 11 times negative 3 minus the square root of 11 plus 6 times that. Well, now I could just distribute that right here, so 6 times negative 3 is negative 18. And then I have 6 times negative square root of 11, which is negative 6 square root of 11. And equals 2, we'll just wait and see. All right, next we have to distribute this binomial. Negative 3 times negative 3 is positive 9. Negative 3 times negative 11 is plus 3 square root of 11. And then negative 11 times negative 3 is another, oops, I miswrote that, sorry about that. Perhaps I was thinking ahead. Always make sure you copy things correctly. All right, so I have another plus 3 square root of 11, and then negative times a negative is a positive. Square root of 11 times square root of 11 is 11. That's going to be plus negative 18 or minus 18, and then minus 6 square root of 11. All right, so now we have to combine like terms. So what do we have that's like here? Let's see, the 9 is like the 11 and the negative 18. Let's see, am I missing anything there? Nope. Okay, so 9 plus 11 is 20. And then I have 20 minus 18, which is 2. And then I have 3 square root of 11 plus 3 square root of 11. That would be 6 square roots of 11 minus 6 square roots of 11. That would be a plus 0. So altogether on this side I get a 2, which matches the 2 I found on the other side. So I get 2 equals 2. Check. Plugging in the other one, and generally if you have a quadratic binomial like this, if one works, the other should work, but we're going to double check anyway. So plugging in, we've got squared plus 6 parentheses, and we're hoping that's equal to 2, and we plug in again. So this time we're going to do the negative 3 plus the square root of 11, which should be easier because there's not as many negatives. And there's nothing to do with the 2, we just have to clean up this side here on the left. Alright, so what do we get there? Well, square means multiply by itself, so that's negative 3 plus the square root of 11 times negative 3 plus the square root of 11. And then we have plus 6 distributes, so that's going to be a negative 18 plus 6 square root of 11. Alright, over here I have negative 3 times negative 3, which is 9. Negative 3 times square root of 11 is negative 3 square roots of 11. 11 times negative, square root of 11 times negative 3 is negative 3 square root of 11. And then we have square root of 11 times square root of 11, which is just 11. Oops, just to be plus 11. And then we have the minus 18, and we have the plus 6 square root of 11. And then like before, we'll combine like terms, so the 9 is like the 11, which is like the negative 18. 9 plus 11, like before, is 20, minus 18 gives me a 2. And then the negative 3 square root of 11 and negative 3 square root of 11 is 6 square roots of 11, but negative plus 6 square roots of 11 gives me a 0, and 2 plus 0 is 0. I lied, it's 2. Don't deceive ourselves there, which matches the 2 on the other side. So that's another check. So both of these answers check. So I have those two solutions, which check here and there. Cool. All right, moving along. All right, complete the square on x squared minus 14x. Okay, so to complete the square, we did that on the previous example. We look at the term by the x, and that term right there is a negative 14. So that's what I call b. Then I take that b and I cut it in half. So what's negative 14 over 2? Well, that would be negative 7. And then I take that negative 7 and I square it. So that would be positive 49. So that's the first magic number I use here. So now I have x squared minus 14x equals 49. Now the point, oops, I lied. Undo. The point of that 49 is to add it. There we go. Now once I have that right there, think about the factoring we did before. 49 is 7 times 7. Right? So remember this factor by grouping we did a while ago, the AC method. 49 is 7 times 7, and coincidentally 7 plus 7 is 14. And if those were both negative, then that would be a negative 14, which is what I have in the middle. So that means this should factor as x minus 7 times x minus 7, which can be written more concisely as x minus 7 squared. So up here, I can say that if I add 49, then this will be equal to x minus 7 squared. So the big picture here is that if we take half of this number here and square it, that tells us what to put there. And then half of that number there is what goes over here. Okay? So we have two key numbers there. And that's my answer right here for completing the square. I built a perfect square given some initial information, that x squared minus 14x. Hope this was useful. Take care. Do good math.